I'm Valérie Leprince, and I will talk to you about the qualification of airtightness in testers in France and the feedback after 15 years. So it actually makes me feel very young, like 15 years younger, because I have been doing a lot of those presentations 15 years ago, not that much since then. It's also a bit moving because, Rémi Carrier was the father of this qualification in France. He's the one that made it possible and made it mandatory. So, of course, it made me think about it. So, what about the history of the French regulation regarding airtightness? So before 2006, basically nothing was happening regarding airtightness in France. There are like 3 or 4% making some tests, not really, well, testing the material and everything, but it was not a thing in France. In 2006, the energy performance label F-Energy came into force, and it was not a mandatory label, it was a voluntary labeling things, but it helped you to get some subsidies. So if, as a builder, if you fulfill the requirement of F-Energy, you can have some subsidy from the government for your construction. So more and more people were going to this label, and F-Energy at that time was inspired by Minergie and Passive House, and so they made mandatory the airtightness test for residential buildings. And that's when the qualification scheme has been created in France, because actually F-Energy was asking for testers to be qualified, and we made up the qualification at that time. In 2012, it was a big change in France because the F-Energy level became actually the mandatory level for every new residential buildings. And so at that time, it made it also mandatory to check the envelope airtightness for every new residential building. In 2022, another new energy performance regulation came into force. And since then, it's no longer only required to test residential building. You also have to test non-residential buildings, so schools and offices that are below 3,000 square meters. And also now you have to check that the ventilation system is actually performing as foreseen. So in 2026, we've got now 663 qualified testers according to the qualification tester schemes in 381 companies. So just for you to know what I'm talking about, when I will show some data in the end, in France, we don't use the N50 because it would be too simple. And then for the rest of the world to understand what we're talking about, so we use the Q4 Pascal surf, which is actually the flow rate at 4 Pascal divided by the envelope area of the building, but excluding the low floor. Don't ask me why, it was even before my time, but this is the indicator we have been using in France for a long time, and the requirement is to meet 0.6 for single houses, so it's more like 2.5 in N50, 1 for multifamily buildings, and 1.7 for office and schools. You are allowed to perform the test by sampling. If you perform the test by sampling, then you multiply your value by 1.2. So if you've got 1, you actually have to report 1.2 cubic meter per hour per square meter. And you can also do the test slightly before completion, but in this case, if everything is not installed in the building, like the range hood or any burner or anything, you have to add 0.3 to your results. So it's a big penalty here. So why airtightness became mandatory, airtightness test checking became mandatory in France? Of course, there is energy use, but not only that. Actually, the regulation in France in 2012 became really performance-based for energy performance. So we wouldn't have put the mandatory value for airtightness if it was only for the energy. We may have put mandatory reporting of the value, but probably not a target. The thing is that airtightness is a key parameter for high-performance building for their durability because it minimizes moisture condensation risk within the wall structure. It's also very important for thermal comfort because it eliminates unwanted draft along the building. And for us, it's also very important for indoor air quality because in France, ventilation system relies almost only on extract-only system, so with extraction in bathroom and kitchen, and with natural air inlets that are located in bedroom and in the living room. So if you've got a very leaky building, the air will take the shortest path to the terminal, and you will underventilate your bedrooms. So actually more leakage means actually less flow rate where you want to have the flow rate, where less air renewal in the bedroom and so on. So that's why for us it's very important to have a tight building to ensure the proper airflow pathway in the building. So you may have noticed that I'm talking about checking air tightness level. Actually, to demonstrate the compliance, builder can choose between two different approaches. Either they do a systematic measurement. When the building is finished, they test the building. Every single completed building is tested by a qualified tester using the standard blower test, which is what 70–80% of builders do, the construction check. But there is another option, which is the quality management that has been introduced from the very beginning, that is used by builders that sell pre-designed homes, and they can propose a quality management approach that needs to be approved by the ministry, and they have to develop construction details, they have to do the planning and checking that's going on with any quality management approach, and most important of all, they have to train the worker, the craftsman that will come on their construction site. So the idea here was to have a maximum of craftsmen that would follow a training to then go to disseminate the knowledge about what it is to build airtight. So with this quality management approach, it allows us to have a better dissemination of the training for airtightness among craftsman communities. Why did we implement qualification tester schemes for stand tester? First, as it's a mandatory, as it's a requirement, we need to limit the variability of the results. So limit the variability in measurement due to measuring device, due to user errors, and to standards misinterpretation. We need to guarantee a uniform practice regarding the results and decision on building compliance. And also, we wanted to know more about airtightness in France, and we wanted to create a network and a data set to assist research and policy making. So actually the same as in UK, we've got 3 steps. First, we make French specific rules adapted to the French energy performance regulation for airtightness tests. That's the FDP 57804. Some other country would have done an annex to the ISO 9972 standard. We decide to make a second text, but that's basically the same spirit here. We've got training that is done in authorized training center following a predefined program. And then we've got the qualification that is given by a qualification body under contract with the ministry. So I have tried to do a scheme to summarize that. So a tester who want to be qualified need to go first through a training center that is approved by the French Ministry for Construction. Then to validate this training, he is trained. Then he has to go through the qualification, which is through Qualibat, which is a qualification body also approved by the French Ministry for Construction, where they verify the tester competencies and the company reliability. And when he is qualified, we assume that he delivers trusted reports that can be used to justify that the building comply with the regulation. So what do we get in the French customized rules FDP 5784? Again, it's probably the same as in other country. We explain how to calculate Q4 Pascal surf because it's nowhere else in any other international standards. One very important thing is that we explain sampling rules. As I say, it's allowed not for multifamily building, not to test the full building at the same time, because it's maybe very difficult to do it, to access all the dwelling. So there is rules that you can pick some of the dwellings and perform the tests in those dwellings to assess the airtightness of the full building. There are specific rules also about the time of measurement and about the building preparation that need to be consistent with the energy performance regulation. What is already taken into account in the energy performance calculation should be sealed, and what is not taken into account should be left as it. There is a part also about the reporting of results and the calculation of the ATEBAT. So one very good thing, one easy thing in France is that the tester doesn't have to calculate the ATEBAT because it's given by the energy design office. So when you design a building in France, you need to go through an energy performance calculation. In this energy performance calculation, you have to put all the metrics of the building. And so as output, it provides you the full ATEBAT of the building. And this is what the tester should use as an input of his airtightness test. So the envelope area is not calculated by the tester itself in the context of the AP regulation. So that's simplifies things here. Then there is a test report that must include a leakage detection. I will talk about it later a little bit. Then there is an uncertainties part, sorry, an appendix about building preparation, about device calibration every year for the manometer, every 2 years for the fan. Calibration points and methodology are provided, so we've got a very strict requirement regarding devices calibration, and an appendix also about leakage qualification. So that was for the customized rules in France. Then regarding the training course, well, it's a 3-day training course. You don't need to have prior knowledge on building. Anyone can follow this course, whatever he has done before. He can have been a baker, or he can have been a carpenter, whatever. It's always the same for any professionals. They have to follow this 3-day course. Most of it is theoretical class explaining the standards, and there is usually half a day, 1 day of practical testing, really using the material and everything. And then they go through the validation of the training. First, it's a multiple choice questionnaire, 1 hour and 30 minutes, minimum 50 out of 60 good answer, and they can do it maximum 3 times. If they don't make it, they have to redo the training. And they also do a solo on-site measurement and solo practical exams. They give the report of their test to the training center, and the training center validate or not their training. And then they go through the qualification body. So Qualibat will check the insurance and legal registration of the company. It will check that the tester has been trained and validate his training. Also, experts will review 5 reports according to a predefined grill that is provided in the ministry website. The qualification body also checks the calibration of the devices, and they record every measurement and raw data exports that are done. I will talk to you about this database. And there is a continuous surveillance, so the qualification is never permanent. There is an annual verification of equipment state, so they have to send their calibration certificate to the qualification bodies. And sometimes also, so after 4 years, usually they check periodic sample reports. They say, okay, send me this report, because every year they send all the measurements they have done in a table, and Qualibat can ask them, okay, I want the report number XXX. They have to send the report, and an expert will check the report. So initially, new company receive a 1-year probationary qualification, and they've got a full renewal, and the qualification is reprocessed every 4 years. So thanks to this qualification framework, we've got a really great national database with more than 570,000 data recorded. It has been established from the very beginning in 2006. It's required that every certified tester have to upload the measurement record in the database. It includes building location, geometry, installed system, raw measurement, and leakage location also. We've got all those data in the database. In the recent year, we also have a new database on ductwork airtightness, as there is also a qualification for ductwork airtightness testers. Unfortunately, the ministry no longer want to pay for the analysis of this database. So the data that I will show you are some years old now, but well, we continue to collect the data. We just have no more money to analyze them. But maybe at some point, we will get back to that, make some automatic collecting of data to ease it. So we have done multiple publications from this database. Well, when I say we, it's mostly Bassam Boujaled and Adeline Melois, who have worked on it since 2015, I think, the first publication about this database. What we can know with this database and what we have published is, first of all, of course, the evolution of airtightness and of the number of tests. So you've got here the number of tests performed. So you see that since 2020, basically, we perform around 100,000 tests per year. And you see that the level of airtightness has really improved at the beginning with the first requirements, and then has stabilized basically more or less around 0.4 for houses. The requirement is at 0.6, and around 0.6 for non-residential, when the requirement is at 1.7 now, and around 0.7 for multifamily, sorry, when the requirement is around 1. We also know more about building properties and their impact on airtightness, because we can actually plot what is the airtightness of building built in concrete, in brick, in wood, or other. We can also plot the impact of the ventilation system that is installed. So you see that we mostly installed exhaust-only ventilation system and very few balanced system here in multifamily dwellings. You also got the proportion of construction in single houses and multifamily dwellings. For research purpose, we also got information about the N values of airtightness in France. So you see that, well, as expected, we are very close from the 2/3 value, and we see the nice repartition, normal repartition here that we got. Another thing that we have done with this database is try to determine whether there were a seasonal variation of airtightness or not. The answer is there is not. So what we have done is plotted measurement done in winter, spring, summer, and autumn. We've got enough data to do the statistic. We plotted for the 3 climates that we've got in France: continental climate, oceanic, and Mediterranean. And we plotted for wood structure and for concrete structure. And you actually see that, well, the mean value remain more or less the same. You may notice that in the Mediterranean area in France, buildings are less airtight. Yes, that's something we did observe. Maybe the construction is it's less stringent in this region of France. We also have plotted like the correlation between QE4 and N50. Some other interesting statistic. Also, something we see with the statistic is those last-minute corrections that are done in single houses. So you see here that we've got a nice half normal repartition for non-residential buildings. There were no requirement at that time. It's almost good also for multifamily building, but here you see for single houses, it's a big step that we've got that we should not have in half normal repartition. And this is because, yeah, actually the builder is on site when the test is been done. It's 0.7. Okay, let's put a lot of mastic everywhere so that we actually meet the 0.6 that we have to meet. Let's redo the test. Yes, we got it. So those last-minute corrections are not very durable usually. That's, I think some of my English colleagues call it meeting the target, but reaching the target, but missing the point, something like that. That's, yeah, still happening, but less and less now. As I was telling you it's mandatory to do a leakage location search when you are doing your test in France. So basically, you've got the tester has to report all the leakage he has seen in the envelope. And so we can make statistic on most occurring leakages. So like, for example, everywhere it's leakage through doors and windows. That is the most important one here. It appears in 1/3 or 1/4 of the building. Then also very important, you've got the leakage through electrical component here. So that's the F value. And the leakage around penetration of the envelope. That's the leakage frequency is something, but what is also more interesting is to see in those buildings with those kind of leakage, do we have a higher permeability? So to try to correlate the leakage location with the permeability of the building, and to find out what are the most critical junctions that we have to deal with. And doing those statistic test, we actually found that the junction between wall and ceiling or pitched roof was really important, meaning that if you've got a leakage there, usually you will lose in terms of your tightness. Same connection between floor and ceiling, be more joint connection with wall, junction with two vertical walls, and lighting components are the main impacting one in single family. So let's conclude. So what we've got after 15 years, we are quite proud of having established a unified national testing standard. We think, improved building quality and workmanship for airtightness and formed one of the largest databases in the world. But of course, we still have some remaining challenge. We need to manage and sort this huge data set and find a way to continue getting all those data in a database and continue to analyze those data. We need to maintain the test qualities over years also. We see that we've got a decrease of the number of airtightness testers. We used to have 1,000 of them. Now it's 680. It's kind of logical because people are more trained, they go faster and so on. But yeah, we need to maintain this test quality. We need to test every new and refurbished building also. When there is a major refurbishment, it's very important to do the test because we see a lot of problem in refurbishment with the airtightness of windows frame. And we need to reach the same result of quality for ventilation audit, also ventilation inspection that we do in the new regulation, in the last 2020 regulation, energy performance regulation. Thank you for your attention, and if you have any question, I'm available for that.